3 halves from u to the 5 halves, is there something left over?
On this one?
Yeah.
Yes, what's left over is u to the 2 halves.
Okay.
But u to the 2 halves is just u to the first.
Yeah, okay. That's crazy.
So I'm definitely thinking C or D. And I see the 2/15 because that 5 and the 3 will make 15. I think I just need to keep going here. See, so I'm not there yet. I guess I have an option. I can keep working with u's, or I can put x minus 1 back in for u. It's not going to matter. Do you got a preference? Like I can do more cleanup work with the u's, with the fractions, or I can put x minus 1 in there. I'm sort of leaning toward keep the u for now. Let's get a common denominator. So 3u minus 1 over 15. So I'm going to take the 15 out. And so I'm still looking at C and D. They both have the 2/15. U is x minus 1, so they both have x minus 1 to the 3 halves. And then I'll put x minus 1 back in for u. And that would get me 3x minus 2 rather than 3x plus 2. That's a hard one, for sure. That's one where you get through and you're like, well, if I get half of them right, I'll pass, right? How about 69? What do you have to do on 69? Okay, so you're right, there's no quotient rule. So don't, there's not a GF prime minus FG prime thing. So you could try U substitution. You'd be spinning your wheels. Yeah. There's something we should recognize. So it won't factor. Well, I guess the top would factor, but it wouldn't help. There's not an algebra trick. Well, actually, there is an algebra trick that we need to do. If the top is greater than or equal to the bottom, do you remember what you have to do? Long divide. Or this one, you'd be eligible to synthetic divide. Either way. You can synthetic divide if you're dividing by something simple like x plus 2 or x minus 5. If it's x squared or 3x plus 7, then you better long divide. So do you want me to synthetic divide this or long divide it? I mean, right, synthetic is easier. On the other hand, long divide always works. So, and it also might be the one you're not as familiar with. So I'll long divide. X cubed plus 0x squared plus 0x minus 1 divided by x plus 2. And remember, on the test, these problems are way spaced out. It's a booklet you get on test day, so that you have room to work. You're not. I'm trying to save paper here, so I'm squinching them all up as best I can. On test day, you get a booklet, and they're way spread out, like 4 problems per page, give or take. So you got a fourth of a page to work a multiple choice problem. Okay, something times x will get me to x cubed. And that something would be x squared. And then multiply it back, so x cubed plus 2x squared. What do we do next? Subtract, good. So the x cubes go away. That happens every time. We force that to happen by picking x squared as the sort of the first part of the answer. So negative 2x squared. Then we bring the rest of the stuff down. So something times x gets me to negative 2x squared. That would be a negative 2x. So negative 2x squared minus 4x. We subtract again. Be careful, that means we end up adding both of those. The lead term goes away because we picked the right thing to go up top. That leaves us with 4x. 4 times x plus 2 would get me 4x plus 8. And then subtract that. And I have negative 9 left. What do I do with negative 9? Put it on the bottom, or no, not put it on the bottom. Put it over x plus 2. Put x plus 2 in the bottom. So we're going to take the integral of x squared minus 2x plus 4 minus 9 over x plus 2 dx. And that's exactly right. That was just the algebra. We haven't even done calculus yet. Although I bet we can pick out some answers starting about now, maybe. 9 over x plus 2, that's going to lead to natural log of x plus 2. And of course they all have that, so that didn't really help. C looks suspicious. Well, let's just do it. So x cubed over 3 minus x squared plus 4x. Uh-oh. I don't see any of them have a plus 4x on there. Did I do something wrong? Or is this answer choice wrong? Let's back up to my long division here. X squared times x plus 2, x cubed minus 2x squared, negative 2x would be negative 2x squared. I think I'm right. And this one is not bad. That's just going to be negative 9 natural log x plus 2. Something. What did I mess up in this problem? I think my answer choice is A, but even that's not exactly right. Because none of the others. Unless I did something wrong on my long division here. There. So I couldn't figure out what went wrong. So synthetic divide. Put down the coefficients. X cubed, x squared, x minus 1. If we're dividing by x plus 2, then the negative 2 goes out front. Copy down the 1. Multiply, add, multiply, add. There's that 4 that somehow disappeared. Multiply, add. X squared minus 2x plus 4 minus 9 natural log, minus 9 over x plus 2. Jumping steps there. So that's what I got when I long divided. So something's not right about this problem. I guess I'm glad I recorded it. So I think the answer choice is A because none of the others make any sense. A's the closest one, but it's not right either. So, yuck, bad problem. I must have copied. I mean, I just copied and pasted these from somewhere, so. They would just throw it out. Like he wouldn't have a chance to. Who would you tell? The proctor in the room, who's not even a math person, they won't. Yeah, but on the multiple choice, they're not going to see your work. They're just scanning them in. But they would do all sorts of analysis on it, and they would see that, interesting, all the 5s miss this problem, so something must be wrong with this problem. If everyone who made a 5 on the test missed this problem, then it's probably something wrong with the problem. They do that kind of stuff automatically, so they would catch it if it happened. Most of the rest are U substitution. 70, 71, 72 isn't U substitution, but you look at your answer choices and hopefully you think, oh yeah, which one? Looking at 72, I contend that you can narrow it down to 2 of those choices almost right away. I mean, if you try U substitution, 8x, it doesn't work. So, what can I throw out? Am I throwing out B and D, or am I throwing out A and C? Which one am I throwing out? Uh-oh, we're arguing. If U substitution worked like this, and I had du over u, that would be a natural log. But that's not what I got. So it's not a natural log. So it's one of those tangent ones, where a is equal to 1 and u is equal to 2x. And so it's arctan of u over a, but tangent has the extra thing in front. It's 1 over a out front, but a was 1, so I think this is answer choice A. I was about to pick answer choice C, but I don't think it's C, because out front is 1 over a, not 1 over u. Remember, 50% gets you a 3, so even if you made it far enough to think, wait a minute, natural log didn't work, I'm not sure on the rest, you're shooting 50% at that point. So hopefully you get a bunch right that you know, and then on the rest, if you can get half of the rest right, then you start going from a 3 to a 4 to a 5. What will we have to do on 73? If the top is greater than or equal to the bottom, got to divide. Although this one, since they're both over 2x, I can just, right, since the denominator is easier, that's a little bit easier problem to deal with. If you hold the denominator and split the top, that's legal. What I might have screamed at you for being illegal is if you did this the other way. If this was your integral, you can't split that up and say you can't do that. But if it has a common denominator already, you can divide that out.
But then you don't have to do division.
Well, I would say we already did division, right? 2x divided by 2x is 1, and 1 divided by 2x is the other piece. So if I integrate that, I get x plus something. So I'm looking at C and D for sure. And yeah, that 1/2 needs to be out front. So C. Ooh, 74, I can tell by the answers. That's going to take some work. I'm going to have to set this up as one of those problems. Where I'm unadding fractions. I need to turn this into two fractions. Oh, you sort of recognize it? You definitely did this in pre-cal. So I would multiply everybody by x plus 2 and x minus 3. And get x minus 28 equals a times x minus 3 plus b times x plus 2. This might be a problem that you would skip and come back to, because it's going to take some work to get there. So if we let x equals 3, then negative 25 equals 5b, and b is negative 5. I forget, I had it up there. I'll look it up in a little bit, how many questions there are on each type. If we let x equal negative 2, get negative 30 equals negative 5a plus b times 0. So a equals 6. So 6 over x plus 2 minus 5 over x minus 3. And we were taking an antiderivative of that. See if anything resembles that as an answer. Let's see, 6 natural log x plus 2. Wait, the 6 needs to go with the x plus 2. Minus 5 natural log x minus 3. B's looking good. Oh, B's not good because of the minus sign. No, there is supposed to be a minus sign there. I think my answer is B. Back here when I set x equals negative 2 to wipe out the B stuff, that's what led to A being 6. Yeah, that's the pre-cal thing. Have we not done that this year? Where we unadd fractions to create two fractions that it sort of came from. Partial fractions is the official name for that. Breaking down one fraction into two others. Yeah, and every year pre-cal teachers are like, "What? Do we need to teach this?" And the calculus teachers are like, yes you do, because it shows up in calculus. Because we can't integrate the original, but if we break it into pieces, then it's an easy integration. Easier. So I'm pretty sure that answer is B. Yeah, see, they try to use a property, but you can't stick the 6 and the 5 in there. If the 6 was a power and the 5 was a power, then maybe we could talk about C being an answer. And D's out. I see lots of U substitution. in your future. $78, I would just straight up pass on because it involves a trig identity, an ugly trig identity. Yeah, I would just skip 78. I'll come back to it in a minute. $80 would be a complete the square problem. Look at 80. It's not a U substitution. There's not an X in the top, so I'm pretty sure it's not. You can also work some of these backwards. Like if I take the derivative of answer choice B, I'm going to have 2x plus 4 in the top. And I don't have anything like that, so I think those natural log ones are out. Answer choice D on number 80. Andrew, I'm not saying this is what you did, but it's what I think you might have done on that, but I didn't like it. If you divide up the denominator and write it like this, which is incredibly illegal, but if you do that, then you would get answer choice D. So your integration would be right, but your algebra was nauseating. Too strong a word?
No, I think that's great.
So now I'm down to A or C, and if I'm shooting 50% on the hard problems, then if I guess enough of them right, I'll give me a 5. Right? If I get half of them right, and then I guess on the other half at a 50% clip, I'll get a 75%, and that'll get me to definitely a 4, maybe a 5. This would be a complete the square problem. X squared plus 4x. Let's see, so that'd be plus 4 minus 4. So x plus 2 squared plus 9. And now that looks like an arctan thing. And I don't know where the 2/3 would come from. I see the 1/3. Oh, the 2 is in the numerator. That's where that 2 would come from. So it'd be answer choice A. Most of the rest are U substitutions. U substitution, U substitution, U substitution. Again, I would just skip 78 and say, that's good. Cosine of 2x is cosine squared minus sine squared. Yeah, that's brutal if they put that one on there. I would skip 78, not worry about it.